This is the circuit board of the Midea Mini Split air conditioner. I'll be explaining how this PCB works, so let's go ahead and I'll explain how this PCB functions. The main point of this PCB is its entry point, where the power supply first connects. If the electrical connections aren't correct here, the PCB will be damaged. Here, the line and neutral wires connect to the PCB. If we mistakenly swap the line and neutral, it's like injecting a slow poison into the PCB. At first, the PCB might work for a while, but gradually it will start to fail and it will usually give a communication error. This is why it's essential to ensure the electrical connections are made properly. Some friends commented that I wasted time focusing on just a single switch, but in my experience, some people still make this mistake and connect the power incorrectly. They think the old AC worked like this, so this one will too. However, let me clarify that new ACs work with an SMPS system, while the old systems operated with transformers, which took in 220 volts and then processed it further. But here, components like diodes and amplifiers are directly involved, and they directly receive power, so there's a higher chance of them getting damaged. Now, let's talk about the voltages. Here, you'll see two capacitors installed, and their purpose is to control surge voltages. When there's a surge, these capacitors absorb it and direct the extra voltage towards the discharge side, DSA, and ground it. After that, there's another capacitor that controls spikes, and two more capacitors handle smaller spikes. Then, there's a line filter in place, which is also used to control the voltages. Altogether, these components create a complete filtering system. Next, we have a ZNR. The ZNR's job is to short circuit if the voltage exceeds a certain level. Specifically, if it goes above 250 volts, the ZNR will short out and create a spark. This causes two things to happen. If a 3.5 amp fuse is present, it will blow, but often a 20 amp fuse isn't suitable here, so it doesn't blow. Instead, the breaker trips because a short circuit allows excessive current to flow. When the amperage increases, the breaker will eventually trip due to the high flow of electricity. Now, let's talk about the PTC sensor. The role of the PTC sensor is to allow current to pass through it, reaching the rectifier. The job of the bridge rectifier is to convert AC into DC. If the PTC sensor goes bad, it will cause issues here. Let me explain when it is considered faulty. When we check it within the system, it should show a resistance between 42 to 50 ohms. If it shows more than this, 300 ohms to 1 kilo ohms and more, then it's not working properly. This increased resistance will reduce voltage and current flow, causing the system to work inefficiently. So the PTC sensor should ideally have a resistance between 42 and 50 ohms to function correctly. Now, let's discuss the bridge rectifier. Its function is to convert AC power into DC power. Here, you'll see 2 points where AC is input, and then it has a negative point as well. This converts the incoming 230 volts AC into DC, resulting in about 220 volts DC, because there's a slight voltage drop of 4 to 5%. After that, there's a capacitor installed to control DC spikes, so if any harmful surges come through, this capacitor will help regulate them. From here, the system directly moves to these capacitors, which are the smoothing capacitors. Smoothing capacitors are an important component of DC voltage and also act as storage. These capacitors help the compressor run properly and smoothly. When AC voltage is converted to DC, pulsations occur in the DC voltage, which can create problems for the compressor. Smoothing capacitors eliminate these pulsations and provide stable DC voltage. They also temporarily store voltage, a backup for the compressor during power supply interruptions or voltage drops. This ensures that the compressor runs at its optimal level and operates efficiently. Along with this, an SMPS system is installed. From here, the system goes to the SMPS, switched mode power supply section. Let's talk about how the switching mode works. When you turn on a switch, it acts like an on-off function, but it operates through some protection devices that ensure safety. This system is equipped with protections and needs feedback to function properly. When the power is on, the chopper circuit activates and generates feedback voltages. These voltages then artificially turn on the optocoupler. Once the optocoupler is on, it senses the voltage levels, meaning the low side is generating voltages, which guarantees that power is flowing correctly. This activates the system. One of my viewers mentioned that we cannot obtain DC supply from DC supply alone, and they were correct. However, SMPS, switch mode power supply, is used to achieve this purpose. If we only provide a DC supply to the chopper or transformer circuit, it will not directly generate DC to DC voltages. A switching IC is used to achieve this. The switching IC introduces high-speed switching in the circuit, effectively converting the DC supply into a pulsed waveform. This pulsed waveform generates a frequency due to the rapid switching on and off. The generated frequency allows the chopper circuit to step down the voltage as required, ensuring that the output remains a stable DC voltage. In the same way, if the AC supply voltage drops, the unit continues to operate efficiently thanks to the switching IC. This IC adjusts its switching frequency when the input voltage decreases. Increasing the switching activity compensates for the lower input voltage, ensuring that the output remains a stable DC voltage. The switching IC automatically returns to its default operating frequency when the AC supply voltage becomes stable again. This dynamic adjustment allows the unit to maintain a consistent and reliable DC output, regardless of fluctuations in the AC supply, ensuring smooth and uninterrupted system operation. Inside this circuit, a MOSFET is installed. When the MOSFET is on, it allows electricity to pass through, and its negative point completes the connection. At this stage, the chopper begins operating, and the circuit is fully activated. Here we have a switching IC labeled TNY279PN. When it turns on, it activates the chopper, which then generates voltages on the low side. This powers the microcontroller and other smaller components, which operate at 5 volts. Other voltages are also generated in this PCB, and one useful feature is that the company has labeled these voltages directly on the PCB. Let me show you the back of the PCB where the voltages are labeled at all points, making it much easier to repair. When the chopper turns on, voltages are generated at these capacitors. For instance, we have 470 microfarad, 25 volts capacitors here, which should have 12 volts each, and another with 15 volts. There's also a 220 microfarad, 35 volts capacitor. These voltages are used for different functions, such as driving the compressor and operating various features. Now, let's explain the 12 volts. This 12 volts goes to a voltage regulator, which converts it to 5 volts. We apply 12 volts at the input, and the output is 5 volts, which is used to run the microcontroller and related components. There are 2 separate 12-volt supplies here. One 12-volt powers the microcontroller circuit, while the other goes to the ULN2003. The ULN2003's job is to take in low voltage, trigger high voltage, and operate a switching relay. Additionally, there are 3 other relays for different functions. 2 operate the fan, and this second relay is used to activate the 4-way reverse valve, enabling heat mode. The ULN2003 activates these functions by turning on the relays. Now I will explain further and tell you where and what voltages should be present so that you can understand how to repair it. Look, the company has made it easy by labeling the volts. For example, there is a point here where 5 volts should be present. Then here we also have 5 volts. And at the last point, there should also be 5 volts. You should get all the necessary voltages at these points. If, for any reason, these voltages are missing, it could be that there is an issue with the resistance, diode, or even the capacitor where these voltages are being generated. If you have a multimeter, you can check the voltages with it, but if you have an oscilloscope, that would be the best tool because it can help you detect any spikes or fluctuations. Now, I will explain the voltages in the drive system. Look, there are 2 capacitors here. One is 15 and the other is 5 volts. If 15 volts are present, it means the drive system will work. The IPM Intelligent Power Module also has some voltage points, and I will tell you about those too. There should be certain voltages at these points of the IPM. If these voltages are present, you can easily repair it, and the system will work perfectly. For example, 15 volts should be here, and then at this point, there should also be 15 volts. Next, there is another system at work, which is the communication system. The communication is controlled by the microcontroller, but it operates through optocouplers. The voltages come in the form of packets. There is one receiving optocoupler and one transmitting optocoupler. This causes the voltages to go up and down, and they send signals to communicate with each other between the indoor and outdoor units. This allows them to understand what needs to be done and the current state of the unit. Now, I'll explain this part. Look, these sensors are installed here, and there are 3 sensors. Here as well, there should be 5 volts as labeled by the company, indicating that 5 volts should be present at these points. There are 3 pins for the ground, and the other 3 pins should receive a positive 5 volts. Often, when these sensors fail, they short circuit, causing errors. Similarly, if you check all points, you'll get a good understanding of how it works. Additionally, these sensors have specific resistors and capacitors. If there's a fault in the sensor, some of these resistors and capacitors are for the sensors and some are for the relays. There is also a capacitor here, which is used to control spikes, protecting the coil on the reverse valve. Also, here's a fuse, which is a 20-amp fuse. I hope you now have a complete understanding of how this functions. Click on the left or right thumbnail to watch our next videos, and subscribe. Thank you.